Hello, and welcome to the Argyle SMB Finance Forum. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsor's virtual booth at any time during today's event and for the following week. Our partner is committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. To ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. Now, without further delay, I would like to introduce our speaker, Nayab Siddiqui, Chief Financial Officer and Head of Strategy, Resi 360. We are excited to have Nayab with us for a keynote presentation titled Harnessing the Power of Predictive Analytics. Welcome, Nayab. Over to you.
Thank you, Nick. Hi, everyone. This is Nayab Siddiqui. Excited to present to you today a very important topic, which is harnessing the power of predictive analytics. Before that, a little bit of background on myself. Currently, as Nick said, I'm the Chief Financial Officer and Head of Strategy for Resi 360. Resi 360 is a technology company which operates in the space of travel, tourism, loyalty, and community. I'm based out of San Francisco Bay Area, working and living over here. And in my prior life, I'd been working in different industries, including investment banking, payments, fintech, consulting, and many more. So so that's what my background is. Let me quickly jump into the topic. A very important topic, something which is talk of the town. Everybody's talking about predictive analytics, and we are going to talk about that and see how we can benefit from these developments that we are seeing. Let's move over. Okay. Okay, so first of all, we need to understand what is predictive analytics. And before going into details, I would like to keep it at a higher level so that we all understand what we are talking about. It's simply a process of using data to make predictions. As simple as that. And then we'll talk about some of the nuances. But it's just data used to make predictions. Now, before delving or diving much deeper into that, I have to give you a small example that is to set the stage right for this discussion. What do we do in our normal lives? Every day we are using our learnings, our data, our information to use some predictions, using our analytics to take some decisions. For instance, if I want to invest in stocks, what do I do? I go back, look at my experiences, which means I'm searching my own data, my personal data. The second step would be I'll go out in the market, start searching for that particular company, its financial analysis, what are the analysts talking about that, how the company has performed, and based upon that analytics, what I do, I make a decision. What I'm doing analytics, predictive analytics using the data which I have. Now, this is a personal decision, which means I've got some information available with my own experiences and some information available from external sources. That's exactly what a company does. But now imagine this is me, who's a single person. I can go into my own historical learnings and good or bad experiences. I can start searching for different data, externally available, publicly available. But what if this is a company which has got thousands of people, which means the data is spread all around? Be it the employees, the owners, the entrepreneurs, the management, or some external data from vendors, from customers, publicly available data, government data. So I mean, there's disparate set of data which is available all around, which means to make a prediction, we need all this data to come together for our help. So let's use this example throughout our presentation. I'll move forward. Now, on the onset, I want to just clarify one big confusion, which is which people are always talking about. People normally use machine learning and predictive analytics as alternative terms. These are not. So machine learning, if we talk about, is a subset of artificial intelligence that enables computers to learn from data without explicit programming. Whereas predictive analytics is something which makes use of machine learning. So machine learning is a subset of the holistic or overall predictive analytics process. So what predictive analysis does, it's a broader term that encompasses machine learning. So machine learning becomes one subset of the overall predictive analytics process. Talking about the life cycle, and I'll keep reflecting back on our initial example where I talked about our investment decision, our personal investment decision, and likewise the company's corporation. They keep making those decisions every day, every minute, in different ways and forms, right? So what we need to do? If we look at our predictive analytics life cycle, the first thing is to identify the target. What do we want to achieve? We have to define the problem. We have to define the objective. What are we trying to predict? For instance, in this example where I've talked about a person who wants to invest, the target is to identify the right stocks which will give me a certain return according to my own wish, will, and objectives. And that's what my target is. So unless and until I don't define the target, the whole predictive analytics process will go for a toss. So the first and foremost thing, define your target. What do you want to do? What do you want to achieve? Second, where are you going to, how are you going to do the analysis? Of course, you have to have the data. Again, in our example, we talked about our own personal learnings, historical data which is available, market data which is available. So second step, identification of data, collection of data, compilation of data, identifying the different data sets that need to put together so that it becomes meaningful. What are the attributes of that data? How we are going to, for instance, again, in that example, the attributes would be, I want to invest in a company which has got long-term, which pays dividends. So that is one of the attributes. What are the different variables? The variables is, for instance, the company is, if the company invests in a certain market, how its stocks would move. What are the different scenarios? So I have to build the data according to all these scenarios, all these attributes, all these variables. So second step. Third step is, now here comes the modeling part, which is the new thing, that is why everybody is talking about it. Because earlier we were doing it all manually, different people sitting together, coming in a boardroom, talk about different things, their own learnings, their own experiences, their own biases, and then putting together an analysis and making the decision. Now it's a little bit different. It's going to be scientifically analyzed, scientifically arranged, and only then, once the data is being validated, information is validated, that models are being built, only then we make an analysis and make a decision. So the third and the fourth and one of the most important part is the modeling part. That is where machine learning, that is where artificial intelligence, that is where the big data analysis, which is helping us now. So this is the bit which is changing the world. So what do we do over here? We do the data validation. We do data building. We deploy and validate predictive models. And what are those models? We'll talk about those in our upcoming slides. But that's the third step. Target being set, data being compiled, identified and compiled, put into a churn, into an engine, which is going to throw out some results, some analysis. The fourth part, once we've got this analysis, we need to evaluate, we need to monitor results. Now I've got, again, going back to the example, 5 different companies. I need to look at their data. Now, based upon my attributes that I've assigned, based upon the targets that I've assigned, now I'm looking at different analysis for each of those companies, and I need to make a decision to invest into one of those or 2 of those, right? So that's how the life cycle works for data analytics. Very intuitive, exactly the same that human beings have been doing since ages, since the inception, but the change is, the difference is the availability of scientifically structured computing models, which are going to help us do all these things in click of a button, maybe very quickly, and saving all the time and resources and providing, impactful and effective results. Let's move on. Now, is analytical, this predictive analytics only helping the financial industry? It's not. It's basically, it can be applied anywhere, any domain and any industry. Wherever there is decision making, this can be applied. Wherever there is data availability, these tools can be applied. For example, if you talk about marketing, we can predict customer behaviors, we can predict preferences, customer churns, their lifetime value, so and whatnot. I mean, you can, there's no bounds. Like, for instance, if I talk about say travel industry, what type of people travel in which time of the year, how many people travel, which are the different sectors, where they start from, where they end, what are the different times in a day where they take flights. Based upon that, what are the food preferences? What should we be offering? Should we be offering media during red-eye flights? When everybody is sleeping, we are offering media. Who's going to buy? So all these things we have to we can analyze now with predictive models. Finance, we can predictive sale patterns, credit risk, fraud incidences, portfolio performances, and whatnot. I mean, most of the people, I'm sure, must be from finance, so they can imagine how many different combinations and permutations we can put together to get some meaningful analysis. Talking about healthcare, disease prediction, diagnosis, prognosis. What are the different treatment outcomes? We can look at the historical trends. We can look at what's happening now. COVID is a big example. With all that learning that we had, now if we put that into our predictive analytics engine and models, we can predict what can we expect in coming years, how things are going to evolve, how the medicine or pharmaceutical industry might evolve. Insurance claim, how it's going to impact insurance claims. So all these analytics, we can use these tools and techniques. Manufacturing, demand prediction, inventory prediction, quality issues identification. What are the returns, maintenance, labor churn, education? What are the we can like predict what is the student intakes. A lot of universities are using these kind of tools now. Where are these students coming from? What is the performance like? What is the retention? How many are dropping off? Where are they coming from? What kind of, where are they falling behind? So all these analytics we can do. So the point is, it's not just for finance. Wherever we have got data, wherever we have got, we need analysis, these are the tools that can help us. Let's move on to the next slide. Now, how we are doing it. This is the third part. When we talked about the stage, first stage was identifying the objective. The second stage was collecting, compiling data, and the third was building the model. That's the new thing. That's the part that we had always been doing, but now we are using the computing techniques to come up with our analysis. If I talk about models, there are numerous models available because they are scientifically based, mathematically based, statistical calculations. But there are certain basic concepts for building these models that I would like to highlight over here. What are those? Let's talk about classification model. What is a classification model? Now, these are models which basically predict outcomes or categorize outcomes based upon such a yes or no type of scenarios, true or false type of scenarios, where you want to opt for one option versus another. For instance, one of the examples could be, for instance, your sales, your customers, are they going to pay on time? Yes or no? Your customers, are they going to subscribe for a certain channel? Yes or no? There are three options available. Which are the three options your customers will opt for? Are they going to pay through credit card, or are they going to pay through cash? So we are classifying each of these decisions in a certain set of, following a certain set of parameters, and based upon that, we are inputting these classification models into our computing techniques, and we are going to get the results out of that. Talking about regression models, which is the second one, what do they help with? They are basically numerical. They predict numerical outcomes. For instance, what is the sales going to be in the next 3 years? How the sale is going to change with when certain different parameters change, certain variables change. How our revenue or profit is going to be impacted. That's I'm sure. I mean, with some of the people from finance background, the regression models is something which is prevalent for, since ages. But that's something that we are using in our predictive models over here as well. Third one is, which I want to highlight, is the clustering model. What are those clustering models? For instance, these are the models which put things into different segments, into different groups. For instance, how baby boomers are investing versus how millennials are investing. What type of products should we make for a certain type of people? Like, I spent quite some time, traveling around the world, and for instance, in certain metropolitan cities, what happens where there's a lot of influx from different for tourists from different parts of the world, based upon their own preferences, the businesses they create different offerings. That, for instance, if during this season, summer season, a lot of customers will be coming from cold places. What type of services do they need? What kind of hotel rooms do they expect? Where do they want to go? Based upon that, we cluster those type of customers and create our offerings. So this is one of the examples for clustering models. Time series model, again, a statistical model where we go for pattern based upon historical trends. For example, we can forecast sales, we can forecast our expenses, we can forecast the upside or the downfall of payments. For instance, the holiday season, where we can see the uptick in usage of credit cards. So yeah, so these are all the models that we can talk about. I'll try to be a bit quick. Benefits. Well, I mean, I've already been touching upon that a little bit, but yeah, first of all, of course, increase efficiency. What we are doing, actually, we are reducing our cost, because earlier, imagine in a 10,000 people company, there are so many people big teams who are churning all this number every month, every quarter, every year, and only in 1 month time, 15 days time, 20 days time, they're coming out with results. But now, with the click of a finger, you can have all these results available. So we are increasing efficiency, improve performance. Of course, our forecast, our demands, our sales, we are assessing them well within time, before time. So we can always identify opportunities. We can move fast. We can be as agile as possible with all the data on at the tip of our hand. Again, going back to my example, for instance, if I spend 5 days analyzing a certain stock, and by that time, the market has already changed. So what is the benefit of doing all that analysis where I can't take the advantage or can't take the benefit of a downfall of a certain stock, where I could have bought that stock with my analysis, but my analysis took 5 days where the market has already gone back. So performance improves. Experience. Once we know what our customers are expecting us to do, we can always create better offerings. We know their behaviors, we know their preferences, we know their likes and dislikes. We can always create better offers for them. So of course that creates enhanced experience. In finance, of course, I mean, we can improve our procure to pay cycles. We can improve our order to cash cycles. Then, of course, if one company is using all these analytical tools, whereas the other one is not, so one which is using definitely goes above and beyond, whereas the other one is still waiting for the right results to come, which means their decision making is not up to the mark. Of course, it provides us competitive advantage. Well, a little bit of reiteration of the same, but with a different angle. So for SMBs, if we look at this predictive analytics tools, what are we doing? We are basically, under data information, we are saving time, we are saving resources, we are saving and utilizing the available data, because in every company, in every organization, there's so many sets of data, but because of silos, they are not linked together. Now with these analytical tools, we can have data integration from multiple sources, accounting systems, CRMs, ERP system, external data sources. So with APIs, data is being linked and everything is churned into one single engine, and we can have those results. So availability of data, analysis can be done very quickly. So data-driven analysis. Now it's not based upon someone's biases or own personal preferences. It's basically data-driven. Reporting. As I earlier said, hundreds of people, 20s of, tens of people sitting together, churning number to come up to a final number, available on a click of a finger. Here we go. So reporting timeline is reduced and standardized as well. So now we have got interactive dashboards available. We've got charts available that can easily be shared with the stakeholders in real time. But what is the result of all this? Of course, timely decision making and well-informed decisions. Of course, we are talking about SMBs. We are talking about finance over here. I've already talked about one of the examples, which is the investment example, which I took as the base example to talk about this particular topic. One of the examples could be our cash flow improvement, our liquidity improvement. So, for instance, if we are already effectively estimating our future sales revenue, we are looking at our procure to pay cycle, order to cash cycle. If you're looking at them and we are doing a deep dive into each, what are we doing? We can improve our sales revenue. We can improve our customer behavior. We can look at our preferences, loyalty, retention, and based upon that, we can very well predict our sales. Our future expenses can be predicted well in time, and that we can always tweak that. A lot of times, most of the time we see with hundreds of different vendors, there are different payment terms. Someone is being paid in 30 days, someone is paid in 10 days. And with the legacy aging analysis, we can only see things to a certain level, but using these analytical techniques, we can drill down to the lowest level, and we can come up with a solution that can improve our cash cycle. Working capital is improved. Cash flow gaps are improved, and we can create surpluses that can be invested somewhere else to earn valuable revenue for the company. And I can keep talking about different upsides and benefits of analytics, but the core is it can be applied anywhere, wherever you've got data, wherever you want to have analysis. You can save time, you can save energies. All the good things about predictive analysis, but does everything are there any cons as well? Well, it's not cons, it's challenges. Every tool has got its own challenges. Every technology has got its own challenges, and so is predictive analytics. Some of the key ones are data quality and availability. Now, what are you dependent on? You're dependent on quality of data. A lot of time, data is very noisy. There is missing data. There are inconsistencies. The data is outdated. It's biased. So if we don't have quality data, we always talk about the concept of garbage in, garbage out. So predictive analytics tools are nothing but an engine which churns data and throw out meaningful results. But imagine if the data is not reliable, if the data is not available at all. For instance, I want to invest in stock, to my earlier example, but I never had an experience of investing before, which means I don't have any personal data. The only thing I'm relying on is external data. But if I'm a novice, the data I might be looking at may not be relevant. So relevance and of data and quality of data. That's one of the things that you have to be aware of. Data privacy. A lot of times data availability is there, but it's the security regulations which stop us from using that data. So we have to be cautious about that. Sometimes the models that are used are so complex that a certain we don't understand those models. And if something is some variables are wrongly being utilized, the model is so complex that a normal person would not be able to understand that what has happened in there, and that might become, for non-technical user, there might be a problem for lack of trust. And then lastly, uncertainty and bias, because a lot of times when we are putting in identifying our objectives, identifying our targets, we might be biased in that. We may not have certainty. For instance, COVID was one of the black swan events that happened. No matter people had been doing all these analytics before, but they didn't have anything like this for the last 100 years. So there was uncertainty around these kind of things. So we have to be cautious about implementing predictive analytics tools. There are many of them out there in the market, but the caution is, have your objective right, look at the right data, set of data, identify it, and don't consider that as a magic bullet or a silver bullet. It's a journey. Embark on that journey, and I'm sure it's going to be very beneficial for all the organizations. So Nick, we are almost on time. We've got a few minutes left. I'll pass it over to you. I'm sure there might be a few questions. I'm happy to answer this.
Great. Well, thank you so much, Nayab. Yeah, here's a question from the audience. Can you make any recommendations on how to start implementing predictive analytics capabilities?
Right. Yeah. So the first step, in fact, three things I'll reiterate. Number one, your objectives. You have to identify the objective. It's not that the whole organization can transform into data analytics, or you start using data analytics tools on day one. So first of all, you have to take baby steps. For instance, if you want to start by, for instance, analyzing your sales or predicting your sales cycle. So start with the objective, see what kind of internal data you have, what is the level or depth of that data, external data that you. And the third one is identify the right tools, because there are several tools out there. It's a hot topic. Every other company is coming out with some kind of analytics tools. Which is the right tool for you, which serves your purpose? So you have to, if you don't identify your purpose right, you'll not be choosing the right tool. And so that's how you need to do it: data, objective, and quality of the tool. Take baby steps.
Great. And here's another question. What role does FP&A or scenario planning play in regard to big data predictive analytics?
FP&A sits in the center of all these initiatives. And as I said, big data sits on one side. Scenario analysis or scenario identification works in the middle of it. So if once you're trying to do analytics, you have to identify the scenarios, and as many scenarios as possible. If you provide as many scenarios as possible, the tool will be able to provide with these analytics. For instance, I mean, I was giving this example about airlines, where there's so many different scenarios that are playing the part. What kind of people are traveling in this time of the year? Is this a morning flight or a red eye flight? Is it traveling from which continent to the other continent? Is it following the winds, or is it going against the winds? Right? What is the carbon emission like? What kind of plane you are using? What is the weight of the plane? So all these different scenarios, all these combinations and permutations make a great part of the whole data analytics experience. And FP&A sits in the right in the center.
Okay, great. Well, thank you again, Nayab, for such an incredible keynote. I also want to thank everyone else for joining us today. This session, along with all of today's content, will be available on demand following the event. This officially concludes the Argyle SMB Finance Forum. Thank you again for joining us today and engaging in our content. Have a great rest of your day.